Hey guys, welcome to lesson 717. Today we're finally going to talk about the tangent function after talking a lot about sine and cosine. So we're not going to graph this one like in detail like we did for sine and cosine, but I do want us to see what the graph is like, why it's the way it is, and also learn how to calculate sine and cosine, learn how to calculate tangent based on the sine and cosine. All right, so the tangent is, in fact, not just its own thing like sine and cosine were as it seemed, but it's a ratio of sine to cosine. So in order to calculate tangent, we actually have to divide the sine value by the cosine value. So, for example, if I were to find the tangent of, that's kind of fat. If I were to find the tangent of pi over 6, let's say, no, we do that one down there. Let's do tangent of 5 pi over 6. Tangent of 5 pi over 6. You can use, sometimes it'll be radians in here, sometimes it'll be degrees. It doesn't make a difference. So when I'm asking for the tangent of 5 pi over 6, you find that on the unit circle, and you use these. And remember, it's always cosine comma sine in those coordinates. So I'm going to do the right divided by the left. So I would do 1/2 divided by negative root 3 over 2. Okay, so that's what I mean when I say sine divided by cosine. Now that's how to calculate it, but first I want to talk a little bit more about tangent and its graph. So this is in fact the graph of tangent, and it's really, really funky, and it's pretty interesting why that's the case. So if we were to look at how to calculate the tangent, right, we're doing sine divided by cosine. In math, it's completely illegal to divide by the number 0, right? We cannot divide by 0 ever. When you try to, everything explodes. So on this unit circle, we want to ask ourselves, okay, well, at which angles would we end up dividing by 0 if we were to try to find the tangent? So essentially, if tangent is sine over cosine, where on this unit circle is cosine equal to 0? Because that's where there is a problem. So that's when I'm looking for wherever the left side is a 0. Hopefully you would realize that this one and this one are both candidates for that. If I tried to find the tangent of 90, I would end up doing 1 over 0, and that's not even possible. Okay, and same thing here, if I tried to do it for 270, it would be negative 1 over 0, and that is also not possible, again, because we can't divide by 0. So, at pi over 2 and 3 pi over 2, we run into that issue, which is why on the tangent graph, there is something called an asymptote at each 3 pi over 2 and pi over 2 interval. Okay, and an asymptote is just a boundary. It's like a fence where the graph can get closer and closer and closer and closer to it, but it will never touch or cross this boundary. And the specific reason for that is because there is no tangent value at these x values. Okay, simply because you can't divide by 0. So if I asked you for the tangent at one of these kinds of angles, you would tell me that you can't do it and that it's undefined. The other thing I want to talk about is what each of these actually means. We've talked a lot about how cosine is for horizontal distance on the Ferris wheel. Sine is the height off the ground on the Ferris wheel. And what tangent is actually, if you think about what's going on here, it's doing sine divided by cosine, which means we're doing a vertical over a horizontal. Essentially, that's the same idea as slope, right? Tangent is doing some rise over run action. So, by taking the tangent at some angle, we're actually finding the slope of the line at that angle. So, what I mean by the line is, if I found the tangent of 30 degrees, that would give me the slope of this line. Okay, that's what tangent is doing, whereas sine and cosine give me horizontal and vertical distances. All right, so now let's do some practice calculating these tangent values. All we have to do is use the unit circle and recall a little bit about how to divide fractions, because we don't want decimals. All right, so if I ask you for the tangent of 30, you're going to go ahead to your unit circle, and let me erase all the things I've marked on my unit circle here. You're going to find 30 on your unit circle and use the coordinates. So I'm focused on 30. Here's 30. So I'm going to go ahead and divide my sine over my cosine. So 1/2 divided by root 3 over 2. So let's write that down. We know we're doing sine divided by cosine. So we're doing 1/2 divided by root 3 over 2. Now at first you're like, what the heck is this? But remember, first semester we learned how to divide fractions. It's actually something you probably learned in middle school. What you do is that KFC trick. So keep, flip, change, or keep, change, flip, however you prefer it. You keep the top one, the same. You change the division to a multiplication sign. And then you flip the bottom one. You flip the second one. So instead of root 3 over 2, you do 2 over root 3. Right, and maybe I should rewrite this in a more easy to understand way. 1/2 divided by root 3 over 2. Okay, so it makes more sense here. I'm keeping the first one the same, changing the division to multiplication, and I'm flipping the second fraction. So now, multiplication is pretty nifty because you could just multiply across. So 1 times 2 is 2, 2 times 2 root 3, 2 times root 3 is just 2 root 3. And this is valid, but then you have to realize, okay, well, these 2's cancel. So really, I'm left with 1 over root 3. It's a dangerous game here where when everything cancels from the top, some people just think there's nothing there, and you might just think the answer is root 3. But that's not the case. There's always an invisible 1 as a placeholder up there. All right, so that's my final answer. Now the next one, tangent of 3 pi over 4. So you find 3 pi over 4 on your unit circle. Let's erase, well, you don't have to. 3 pi over 4, it's not here, not here, not here. Oh, here it is. So let's circle it to bring attention to it. All right, so here's my sine and cosine. So it's going to be root 2 over 2 divided by negative root 2 over 2. Root 2 over 2 divided by, let's try that again, negative root 2 over 2. Okay, so same exact process. Keep the first fraction the same, change division to multiplication, and flip the second. Okay, now we just multiply across. So 2 times root 2 is just 2 root 2, just squish them together. And then 2 times negative root 2 is negative 2 root 2. So what you need to realize here is that the 2's cancel, the root 2's cancel. So before you just say the answer is 0, remember that there's always placeholders. Okay, there's invisible 1s on all sides of fractions. So really, we do have a negative sign left over, so we end up with 1 over negative 1, and that just equals negative 1. Right? And if you think about it, we're doing root 2 over 2 divided by negative root 2 over 2. That's the same idea as if I did like 3 divided by negative 3, right? You would pretty easily look at this and say, okay, well, this equals negative 1, right? When you divide the same number by each other, it just equals 1. So it's the same idea. So all the middle angles, like the over 4 angles, those are all always going to be 1 or negative 1, which is pretty convenient. All right, one more. We have tangent of 240. Let's do... So let's find 240 on our unit circle. It's right over here. And so the sine and cosine, here are my coordinates. So we're going to do right side divided by left side as always. So root 3 over 2 divided by, negative root 3 over 2 divided by negative 1/2. Negative root 3 over 2 divided by negative 1/2. So same exact process. Keep the first fraction the same. Change division to multiplication, and then flip the second fraction. So negative 1/2 will turn into 2 over negative 1. So now let's go ahead and simplify. Negative root 3 times 2 is just negative 2 root 3. You could just squish those together. 2 times negative 1 is negative 2. So those negative 2's cancel, and since the root 3 is on top, I do end up with just an answer of root 3. Now there is a 1 placeholder at the bottom, but the nice thing is that when the 1 is at the bottom, dividing anything by 1 doesn't actually do anything to a number. So this you can just say the answer is root 3, whereas here you couldn't say that because it's different when the 1's on the top. All right, so these are actually all 3 options number-wise for tangents. All the tangents on your graph will be a positive or negative version of these 3 numbers. Okay, so we can use the symmetry on the wheel to figure out all the tangents, just like we did for sine and cosine in the coordinates. So that's something you can think about to help you figure out tangents. But make sure you know how to do this because you will need to do this on the test or quiz. So I know it's been a little while. I'm posting this video a little bit late for those of you that are actually watching it. But give those tangent problems a try if you haven't already.